Hello, welcome back to the stream. I'm Jun-chan and we're working on Purescript and using the React Basic framework for user interfaces and trying to mix that with Purescript React Explore, which is using comonadic approach to UIs. And we've been working on that for a while now and going back and forth, deeper into the weeds and back into the bigger picture. And one of the things that I've been trying to do for a while now is to create effectful interpreters. So in a way that would allow me, for instance, when I'm incrementing a counter after reacting to some key up event, and sending an increment value, then I'd like to be able to do some effects, like writing to the database would be a typical example of something we'd want to do right here, for instance. Yeah, and I've been trying different things. Last time I tried to return an effect of counter interface counter model. Right now I'm trying to return a counter interface of effect counter model. But one of the things that seems to be the case is, or like maybe another approach to look at where the effect should be occurring, is that clearly they need to occur when we're actually, what is in effect like this pairing of the monadic value and the comonadic space, the monadic action and the comonadic space, really is a sort of a continuation passing aspect. So when we actually finally call the send callback in that effect, that external, that DOM event, when we actually use the send, then at that moment, that's the moment where we actually, in some sense, do the pairing, which is really provide that monadic value to the comonad so that the comonad can actually advance. And that's pretty much exactly where we'd want to execute the effects. So one of the thoughts then is, well, okay, fine. So should it be here? Hey Barry, what's up? Good to see you. How's life? I usually take a nice long break between my work and my stream, but now I just like straight up, sent a message to sign off work and then jump straight into the stream. So it's one of these days. Bumping your font a tiny bit. Yeah, of course. Yeah, I realized that I've been doing things in a fairly small format. This is plus 200. Okay, plus 250. Is that a little bit better? Life is great. Excellent. Really glad to hear. Hope you had a nice time with your family over the weekend. Are you still working on your typing skills? Right. So, I mean, we could do effects here. We could also do effects here because, or actually here, because set state is also expecting something that is in effect. So we could extract a value out of set state, where I don't know actually set state, does that even return? I'm not even sure whether it returns a value or not, but for now we could actually probably just, I think set state takes something from unit to effect unit. So we could instead do effects here, right there. Day 3 with the advantage 2, and I'm mostly back to touch typing. Ah, right. Okay, that must be a keyboard, I suppose. Let me take a look at it. Probably not that thing. Ergonomic keyboard, that guy. Ah, yes, wow. Crazy stuff. Yeah, I'm using good old Logitech MX. Not, yeah. Well, I'm not willing to take the hit, the loss of the temporary loss of productivity in order to improve my long-term productivity. It's you must find a nice spot to do that, right? Yeah, of course. Then that's when the body says something, it's important to listen. All right. Okay, so I'm still trying to do. I'm basically now trying to mix the community QI work that Phil Freeman did with a library he called React Explorer, and then there's a more recent library called React Basic in the Purescript ecosystem, and I'm trying to mix those two. And at the same time, I'm trying to find out where I can actually have, or how I could have interpreters with effects. Excellent. Yes, that's good. Really happy to hear that. So yeah, so if I look at where my effect should actually occur, then they should occur in here, which is really what I've been saying. It's kind of an event loop in disguise, because it's using that set state, the React set state, to sort of trigger the re-render and pass the state forward, which is really actually sort of threading state, or allowing React to thread state for us. So then the question becomes, okay, well, fine. So does move become effectful? I mean, move right now is actually pure, right? It's, I mean, right now I started to work on making it not pure just before leaving last time. But to be honest, actually, that's still, I mean, what's up if the monadic value is actually in the input? As long as I don't return into effect WA, then I'm still pure. So here, yeah, here I'm saying returning MC. So I think I'm saying I'm returning effect WA. And if I do that, then in theory, what I'll be doing is that I'll be executing the effects in S and then returning S to set state. Which, let's double check in Purescript React Basic, that set state takes an effect state, I suppose, right? That's what we want. Purescript React Basic, React Basic. And yeah, it's probably going to be DOM, I think. Is it? Pursuit is slower and slower. And yeah, apparently it's it must be getting hammered a bit hard on the web on the web server side of things. Oh, that's sad. File is locked. Resource management is hard. Okay, set state, not here. So maybe it's in React Basic Classic. Yeah. Set state takes a function from state to state and returns effect unit. Right. Right. So I'm wrong. This doesn't work. This absolutely doesn't work. I do need to do my effects here or there, and then this needs to move M state. Well, that's yeah. Huh. Okay, so maybe it means that I need to have S be move M state and then set state S, right? All right, let's call it, let's be nice to ourselves and call it new state. So we set state ignoring the previous state and creating the new state. So in that case, move can be now returning in effect WA. So that's good, I think. Maybe that's what we want. And yeah, maybe it is what we want. But in order to find that out, I mean, I could try and do things pretending I don't have just returning pure things. Let's just be a little bit courageous here and try. Okay, so here if we pair Coty, first of all, we flipped here. I don't know if that's going to matter or not, but we take the WA first. Perco, yeah, no, that's fine. Takes the duplicate W first, so we're good with that. And then, right, so we have this function. Yeah, the problem is this function is pairing this F is the pairing of the what? The A with the B. Yeah, it's the pairing of the A with the B, but returning something in the effect monad. The problem with that, first of all, what are our A's and our B's here? Is it really our WAs and our MB? Hold on, let's get back to our pairing and our pairing examples. So tuple, everything still takes an F. Which is something that will, where do I use this F? Well, The answer is I don't, because I use const here. But nothing tells me that I should do that. In fact, I believe we can call this somehow interpret. And in our case, we're going to return an effect WA. Isn't that the case? And for now, we can return pure X. And then what? Ah, yeah, then we have the problem that we don't have runCoT, which is, of course, problematic. Or no, we do have runCoT. So what are we doing here? M. Ah, right. CoTWMB is this thing. But a CoTWMB has what shape? CoTWMB. Oof, that's not going to be. runCoT is just going to run the thing. But okay, let's try and think through this. So this guy is this. So CoTWM, yeah. And yeah, what? runCoT. I regret changing this now. No, I'm trying to write PairCoT. That's what's happening. Yes. Okay. And I'm trying to do that based on PairCo. Isn't that right? Yes. And PairCo is this, and therefore we would think that, well, we'd think that PairCoT would be runCoT COW map FW. Okay, this seems to compile. Okay, apart from that, M is in unit. CoT effect. Ah, right. M is CoT. It's not CoT yet, so we need to make it so. Which would probably move the goalpost a bit. Render now. Render now, maybe because of the type of CoTW. Oh, right. Because of the type of this guy, CoT. And for now, let's say it's in effect. Let's. Oh, Well, compiles. Okay. Now let's try and run it. How about that? Right, and we need to be ready to explode our stack and other shenanigans. Indeed. Seems like we're already doing that. Okay, cool. I think I was able to break that cycle here. Yeah, there's no way that this all connects, of course. So yeah, right, because we were trying with unfold prime, and I think we need to go back to unfold. Do we? I think we do. We'll still have some type problems. Yeah, because we're going to need, what are we going to need? I'm going to need some strange unfold again with some monadic stuff. So that's indeed, that's what we're trying to do with unfold prime. Unfold m prime is also the same thing, right? With monad rec, which we should be fine to use. Right, except that instead of returning m of cofree ma of cofree fa, we're trying to return cofree f of ma. I don't even know if that's the right thing to do, because now we know where is this variable c ambiguous. Where is that c here? MC blah blah. Must be it, right? The values c and b and using the perfect polymorphic type that introduces it. Right, yes, okay, because there's this for all already right there. And W is shadowed. Where is it? Type variable W is shadowed. Oh, because there's a WM props up there, so we don't actually need to say W. We probably don't even need to say functor because we know that we're comonad already. But we'll want to use actually that's not right. Percoti is something that should live definitely at the top level. In fact, we should write it. We should move it into the library, which I suppose we could do right now. And that might go into pairing. No, it should probably go in here. Let's just write it here. Percoti. And Percoti. Then in Explorer, we can import it. Okay. And right, so yeah, what I was saying is we now have an effect but it's in our monadic action, But don't we want it actually in our interpreter instead? Because that leads to something I've tried before, right? Which is to put the some analytic action here in the sort of action, right? But I'm not so interested in that because I want to. Okay, I've been saying from the beginning that I want to swap interpreters possibly, but I mean, this looks like possibly swapping interpreters, doesn't it? Yeah, it's just that this interpreter is what makes up the comonad. So I suppose I do like this, the ability to do different monadic actions inside each of these things, so they're returning this effect counter model. So we do need a different unfold, and maybe that's what I should be doing. And if we have the different unfold, I don't think we actually need this sort of effectful the UI that awaits for monadic actions in an effect monad. So I think we actually don't need that. Which is strange. What if we say that we have a comonad of, well, with some value inside that are effects, basically, right? So maybe effects props here. Don't know if that's needed because our UI type is already something that, well, it doesn't return in effect unit, it returns in RJSX, right? So if we returned here in effect RJSX, maybe that would be what we want. It almost looked like our handlers could be pure. Is that true? We could send something. Yeah, I think that's the case. Our handlers could be pure. It's only if we wanted to do some, if we wanted to write our effects here, then we will need them to not be pure. Okay. But it needs to modify the React component state. Right, so that's why here it returns in effect unit. So it's only to allow modification of the React state. That's send to be in effect. Okay. We have the comonad. All this would work without changing what I have, and then in theory yeah, I'm still a bit doubtful that actually I can make this F here anything interesting. Because Perco T, which we moved all the way here, takes this A to B to MC. And I thought that this was like tightly constrained, but now I'm not so sure anymore. Maybe it was a different case in which it was tightly constrained. Because I thought that when I was playing with the pairings, actually I think I have a note for that. Right, it was explore. For all A, B, F, A to B, G, A to M, B. Hold on. Let's go check out what explore M was. Oh, actually it's here, I think. Yeah, explore M. Right, so this guy I think is too constrained because of the fall XY. But that's not the same as what we're doing. It is actually, because this is also for ABC. In fact, this has exactly the same shape. So we wrote the only possible interpret here, which can return something in effect, but it has to be the empty effect. Can't be any specific. I mean, it could be. It certainly can't be a dynamic effect. I don't think, because I think here I'm missing some universal quantification. I mean, at least. Is that right? Is it WA here? I think it would be just A actually. Yeah, it is just A. Why does this compile? Because, because I suppose this could be A, and this is just effect A, and that's fine, that's the same. Is that right? No, it is not right. So then is Percotti actually something a bit different? I mean, the fact is that I actually removed the universal quantification from this guy, and that's bound to be a problem, right? I think I have to re-add it, which can probably be done with the Tensor. No, but no, I don't have a. Yeah, I don't have I need a pairing M for this if I wanted to go all the way. I need a pairing M FGM with M in there. Yeah, and so M could be chosen, but ABC to be existentially quantified. Existentially, maybe that's not it. Maybe that's actually universally. No, I think it's existentially here. No, but I think I'm interpreting this a bit too. I'm having an hallucination here. Like the F is just a way to do something with your A and your B, and that allows you to, in some sense, ignore the functors there. So you can freely choose C to be M B, or even M of GB or G of MB. Actually, that's totally fine. Okay, hold on, it's interesting. Okay, I think that's the reasonable. Okay, so if we say M here, we say, well, M GB. I could even say, yeah, I think we want MGB somehow. Then we could just say, well, then that's NGB. Right, which is what we're exactly what we're trying to do here, with F being TW effect blah. But then interpret has a weird type. Yeah, I would think interpret would just be A. Is the fact that we have duplicate here significant? It is, of course, because it means that our WA is a W of WA. So here we actually do have access to the comonad here. So possibly this interpret there could do something based on the W. Now, how would I even get it? Like, somewhere inside W, this lives. But we don't know how yet. We don't know how to fold it properly or unfold it. You know, I'm going to do the same thing I did when I was trying to deploy Accelerate on Windows. I'm going to put a cap on myself so that if I actually don't make progress in the next few streams, then I will move to Halogen. Yeah, I think that's probably a smart move. So let's put the date here and paste and say, well, we are at number 4. I think number 10. Okay. And we get back to the program. I don't know why this keeps opening files. It seems to be opening reverse to usual. Maybe that's really strange. Something has happened to my oh no, it's because I reach out for the other for the command tilde instead of the command the alt. Yeah, okay. So log, and yeah, I'm doing it again, and Purescript React Basic. Okay. Okay, so we're saying the more I look at this, the more I think we don't need to have an effect in the action, the monadic action. Those should just be sort of, yeah, something that triggers one of our interpreting functions. Okay, so let's go back. Let's call it explore T. And let's go back to our regular types here. Here maybe we'll change, we'll keep that. Yeah, no, we'll pair code, but there we'll say that our C is weird, and that should still work, which is interesting. And then let's see. Okay, well, that's just a warning. So this would compile, possibly. Okay. Let's call it WA. So here we could do something with the WA. I mean, particularly I suppose if A was also in effect, then we do some kind of distribution again. Although here we just need to extract it and then put it back. Huh. So okay, so let's imagine, let's go a little bit further there. Let's say that we're kind of saying that our carrier type has effect in it. Right, but it's not props, because here component W props actually still takes a value. No, it doesn't. W. So the values inside it are of this type. Yeah, which leads back to if I have effect here or if I have effect here. Let's try this. It's kind of weird, but What does this break? Breaks render. Yeah, because I suppose extract blah would be effect. When we extract would be in this effect UI thingy. And render. Take a self and return the JSX. That seems wrong. It seems like I'm rewrapping it now. Even if we pushed, because the other thing that seems maybe interesting is to push effect here. It would still break exactly the same thing, but now it feels like after we extract, we could get like we'd get a JSX out of it, wouldn't we? Then we could return it. That would not work, right? Because we have I think we have effect of effects somehow. To match effect JSX, which is type T2 of T2, T3. Could it just be something like actually new state? No. Yeah, you see I've tried to do something like that right here. State. Yeah, I think we're prevented to do that. I'm wondering if this complexity comes from the fact that we're kind of called back by React. Like React is really in charge here, and so in fact that we need to use those lifecycle events maybe in order to actually do effectful things like did mount and did update are in effect, but render is not, right? And that's the reactism, that render needs to be pure. Indeed, indeed. Indeed, indeed. I think that convinces me that in fact I'm mistaken. Like they're trying to, I mean, I do want to try and just put a log here and go back to the normal formulation and just see whether here actually displays where I expected. And that would mean letting go of all this. And I believe that would be it indeed. And says rebuild. It does. And here we would reload, or rather reload. And it would work, and it would display here each time I hit a button. So that does work. Including this idea of somehow creating something effectful here that might depend on WA. Very inelegant at this point, really doesn't do much, but it means I should be able to also logger there. Indeed. So this is a kind of this is one of the problems with this formulation, by the way, which is that even though it looks like it's inside render, really when we're calling this send, we're actually not inside render. We're actually inside on key up. And that's why we can be effectful. Okay, so we decided that RM, we don't use RM to give a particular, to create particular effects. Well, in truth, this is right now where we're thinking things could potentially be effectful. And here we have the WA at hand, so we could explore it. And well, in theory, Yeah, we could pass something with unit if we had a CoTWM unit, but we don't want to do that. We want to only be based on our WA. And since we only know that it's a comonad, we can only extract and duplicate from it. And really, we want to extract. And if we extract, we get this UI. We sort of said we can't have effect props here. Could we somehow defer? Could we make this kind of a continuation somehow? So we pass the interpreter to counter. Or explore, we take a counter and an interpreter, and then the interpreter will nudge itself here somewhere, sort of. I mean, it would be in the W, so I don't think it makes sense, but what is our WA? Like if we're looking here specifically, it is a component counter props. A counter being our comonad, being the code-free counter interface. If we extract, we get an A, which is a counter interface. So indeed, we can pattern match on this, right? Are we gonna have? But this returns the A. Whereas here we'd be consuming the A. I'll take a little break. Okay. I'm wondering if I could push if I go back to having effect of counter interface counter model to try this out, I think that maybe is more tractable than counter interface of effect counter model. But I'm not sure. I haven't really tried to make types align right with unfold prime. But Yeah, but what's unclear is, in any case, what does the comonad carrier type look like? And we're back to where we squeeze in effects in the component type, and we saw that putting it here won't work. I suppose yeah, I suppose it doesn't mean that putting it here won't work. Which is a bit strange, but I think it would mean that we need to return in effect here. But I'm not even sure that will work. No, it probably wouldn't work because then our comonad carries effect, and so we're stuck. How come we're not stuck when we use Coty effect here? Is it because of a covariance contravariance thing? I think it is. I think effects in contravariant positions are fine, but not in covariant position here. And handler, this effect is in contravariant position, which is not super easy to see, but it is. The weird thing though is that it's apparently with common DQIs there is a base monad here, and that is in covariant position. But explore then takes something that interprets base into interprets into base units. No, but base, right, what I'm looking for is base action and UI base action. Component T is actually not used in these examples, right? Or maybe it is, but maybe in one of the component T that is base. The constructor, show me the constructor again. Yeah, base. So it is in effect base. This stuff's pretty important there. Execution of melodic action in the base monad with access to the current state of the component. In response to every user action in the component T. You're running get tasks on the comonad. Select takes a comonad and a monadic action. And get task takes so save core3 is this guy, and that creates an action A. Use unfold core3 T, which I remember how to build yourself here. It works for any functor f, and that's what you're using. No, but that's, yeah, f. Yeah, f is the functor for the core3. So this is a comonad transformer with which wraps a core3 T inside a W, which is fine, but so what I'm thinking about right now is that this idea of swapping an interpreter, given that the interpreter really is the content of the core3 comonad here, it means that changing interpreters really means changing the nature of the component. So it makes sense that changing to an effectful interpreter would change, would mean being in a different comonad. But then I suppose do we want to play a bit with our comonad playground here? And this compile. I'm thinking maybe I want to try again something like some comonad that would be, let's say, a cofree of some functor, like some interface. And then maybe, yeah, something like effect unit. Well, yeah, or A. So I'm going to move that whole thing elsewhere. I guess that makes sense. Right, so something like defer cofree tuple and tuple pure unit and no, not tuple. Well, depends what interface is. I think we're saying something like inc and deck, something like that. And then we would wrap it with right. so how's this work already? Oh yeah, this whole ledger thing. Embed takes the FT to T. Right, we ended up with these things, and right, embed my, well, it works for a product type, a sum type as the base functor. But that's for free, right? Yeah. So there must be something that works for co-free as well. But for now, I think we want to do the same kind of trick that we did here. So I'm going to get this guy close to us and use that as a model. My C being what? So the pattern is something like the Foucault free pure unit G maybe, where G is going to be of type I'm trying to return into string here. Well, let's find out if we can. I'm not taking the model right now. So I should probably move over there. And move some of that as well. Okay, so let's new type. Okay, now we have types. Are we using? No, we're still using. It's good type inference here. I'm surprised. G is interface, co-free interface, effect unit. So it would be something like an ink. Or an interface further of an ink. And a deck. Of Comonad or something. Cycles. That works like that. Okay. I suppose here we could do something, right? Especially if our comonad is actually like into effect unit now. Let's do variations here. And we could even do log show I and pure unit and interface blah. Except we need to call this prime. But it would work. And what would we be able to do with such a thing? Possibly we could explore it, but let's instead do what? Well, we could just extract com. That will give us a unit, right? Okay, so we need to first extract the unit and then show it. All right. Okay, yeah, that's true. I think we can derive that. And seems to maybe be able to run. And comonad playground as Spago run. Yes, we need to fix explore first, which needs Torti, Kofri. Torti over there, so these guys too. And comonad itself. Yeah, you know what? Let's just take everything and let everything be okay. I see. So even that's not enough. Tuple. Okay, and now we can say just apply all suggestions, and we do same thing here. And that has some duplicates. And so does this. And we have some small details. Right. In fact, this is fully applied. And just a little shadowed variable. So let's just say y. And then run. We exceed the call stack. And maybe that has nothing to do with the recent example we've shown. It's probably more like the run simpler that I think blows up the stack. Yeah. And this. So I suppose I haven't done my my basic homework there, because if this wasn't working, then I don't see how I would have made the rest work. But yes, at least we have the unit we were expecting. And therefore now if we say instead com prime, how is that going to work? We're going to need to, then that's going to be a function, and we need to log show f1 or something. Is that right? No, that's not going to be right. Extract com prime is going to give me an effect, an into effect unit. So I'll just need to do e prime and log show e prime. But no, because f can't be applied to 1. Why not? Yeah, I think it's just maybe. Yeah. So not very interesting, right? I mean, it should log, yeah, it logs 1 before displaying unit. Let's make sure. I mean, that's more JavaScript, question of JavaScript, but 1 before and then unit. Yeah. Yeah. I don't know if that's particularly useful. It doesn't seem very exciting. Obviously here we're also not using any pairing or anything like that. Is this co-free of env int something? And how do we build a co-free? With co-free prime or t? Lazy computation, right? Okay, so this I believe. Just need to import it. And let's look at this. So f is the functor and w would be the transforming comonad. And so here we want to be first wrapped in the comonad, so we're actually moving this here, if that makes sense. Doesn't make a lot of sense, but let's try. And you still want an interface here. No, you don't want an interface here. And it would make sense that you get a function from I, because that's the wrapping W, right? I think so. It just looks completely ugly. So let's try and do it in a way that we can see a little bit what's going on. And this is going to be a little bit strange. And I think we've established this doesn't work. doesn't. We're supposed to have a tuple of an A, which is an effect unit, which is this, and of a F, which is our interface. Wrapping a cofriti blah. So yeah, no, this sort of should work, I think. But you can't match tuple with function. So here you want another function. Get the unit. The W. Are we using the right cofriti? Looks like we are. Maybe we need some brands. No. So you're saying here you want a function. I mean, that sounds weird. Yeah, no, exactly. That's what I thought you would want. You would want a tuple. And maybe you're missing a parents here. Oh, cool. All right, so wow, it was a question of parents. Not the best, but it is what it is. But probably not those, right? Ignore those. Just those, just the tuple ones. Okay. And what if I'd done that, or this maybe? No. Yeah, seems like that's needed. Okay. And so now to run it, I should have kept the other version really. Exercise. And second. And then we should actually be able to extract, but I suppose what's going to happen when we extract? Get a WA. Yeah, so in that case, that is the way I was looking at it earlier. Okay, prime and U prime and F prime 1. Is that right? Yeah. No. Currently we just get a unit there. That's a bit strange. Run graffiti. Ah, right. Oh, okay, I see. Yeah. That's actually an important distinction. Extract is just getting right to the bottom comonad. So we really want run graffiti. We need to import that. All right. It's not because that's giving us a tuple, which is weird. I suppose, yeah, no, we can't even properly, hold on. Yeah, f prime is of type 2. Yeah, that's it. So I think that's what we're doing, right? No. No, it's not. We still need to extract that. So no, not that. I think I should really let stuff here. I'll be clearer, I think. Run graffiti, unpack graffiti into the inner computation. Whereas this just gets what they call the annotation. Run graffiti, I think, is just one. What? M is a monad? You can't be serious. That's not the case. Here, M is a monad, but there's no explanation there. What the... Okay, that's all very confusing. I think really that's not the case. That's can't be the case. Why are you like this? Graffiti. Arthur Xavier's W is a comma or not, and this is called co-resume. And so co-resume what makes it so that you can extract and then get either an A run co-free is it the same? Okay, I think I will submit a little drive-by pull request here. Okay. Okay. Run co-free. Free run co-free W tuple. Yeah, if you W tuple A instead, yeah, maybe I should also fix this. Yeah. That's co-resume, and we want to run co-free, which could just be pattern matching on the co-free if it's exported. Looks like it is. So let's try this here. Co-free T of F prime. Then we pass unit to F prime, and then we finally get a 1. Is that a thing? Oh, hold on. in that case, it's just well, to be honest, it's just another let clause. Yes, because that's going to if oh unit, right? So unit would want to extract that. That's a little bit terrible already. And then that gives us a tuple. And no, but it's because I'm not clear about the env comonad. I think so. Comonad. And is there a function instance? Well, if there is, they're not defined here. There is extend for function here. Here for function. From W, with W being a semigroup. I mean, int is a semigroup, but is that what's happening there? We know how to duplicate. F prime unit is this. So we just give it a 1. Huh. Well, that's very convoluted. Very convoluted indeed. So what do I have here? I have something I can't really make sense of quite yet. I mean, I'm not clear about whether I've gained anything here. I mean, compared to this. Well, no, yeah, I do gain the ability to actually use I somewhere here if I wanted to. Whereas here I was restricted to using I in the annotation. So that is kind of a pretty big win, actually. But then, I mean, I couldn't find any library function that would help me do this ugly thing. Obviously, I don't need to do UU prime, and I haven't even tried to run it, by the way. But yeah, it seems to be working fine. And yeah, so next time, what would I try? I think I want to try and make this look a bit more like an interpreter. Whether it's useful or not to have co-free T here is unclear, since we actually do use co-free in component. This being our UI type. You know what? I'm realizing something. And maybe I'll write this here as a parting thought. Component is a comonad of some co thing. Of that same comonad unit to effect unit to some JSX, right? And co is a to, where is co exactly? A to R to R. Something like that. Let's look at where it is exactly. Co. WA to R to R. And so really we end up with this crazy thing of W of WA R to let's see what is or R is for all, so W is W, and then unit to R, and that to effect unit, and to JSX. I mean, how weird is all this? But also, I mean, the fact that co has a look a bit like component is a little bit conspicuous to me. I mean, it clearly it's not exactly that, right? Because here we have W of, let's say, some, let's call it I, to something specific, again, a J to something specific like a K. We have this double inversion of control for allowing our send function to be threaded inside, to be called by React, and then co is this weird construction in itself that really uses all of this as an A, right? No, well, yes, actually, because yeah. Well, uses unit as an A here. Yeah, uses unit as an A. And the for all really matters. I'm trying to find a Unicode for all. So I have one lying around. I thought there would be one close to the butterfly symbol here, but there isn't. Yeah. I'm just wondering whether we could move some of this machinery. Could we just have a W? Because could we have a W of JSX and move the machinery to respond to events elsewhere? was the necessity for this specifically? I mean, it was event handling specifically in React. Okay, well, that's it for now. Doesn't feel like I've made a lot of progress. Feels like I'm kind of exploring this without quite knowing where to go, and definitely still don't feel like I'm mastering some of the complexity that I'm tackling. Thank you, Barry. Thanks a lot. And yeah, so it feels like definitely lots of flailing and learning, but it means that's probably exactly what I should be doing, because that continues giving me more intuition about comonads and so on. But at least I put a cap on myself. I'll just do 5 more streams trying to figure this out, and then I'll give a shot at Halogen. All right. Take care and see you on Saturday. Bye-bye.